In this session, let us solve a question from CSIR NET, December 2024. The question is from complex analysis. We are given the complex integral. The contour is unit circle centered around the origin and the direction is counterclockwise. So the function given here is f of z is equal to z raised to 4 e raised to 1 by 2z. Now whenever we have in the numerator of the function a term like exponential plus or minus a divided by z minus z naught the whole raised to n, instead of exponential it can be cos hyperbolic, it can be sine hyperbolic, it can be cos, it can be sine. So functions like this, inside it this is the term and n here is positive integer, a is constant. Alright, so if some function like this is present in the numerator of fz, then z equal to z naught will be essential singular point. Now let us consider the function given here. In the numerator there is e raised to 1 by 2z, e raised to 1 by 2z. Now this can be written as exponential of 1 by 2 times z minus 0 the whole raised to 1. Therefore here a is equal to 1 by 2, which is a positive constant, and n is equal to 1. This is a positive integer. Therefore we can say z equal to 0 is essential singular point of f of z equal to z raised to 4 e raised to 1 by 2z. Now this singular point z equal to 0, whether it is lying inside the contour or not, that you have to check. The contour given is unit circle centered around the origin and the singular point is z equal to 0. Of course it lies inside the contour and the direction is counterclockwise. So if direction is counterclockwise, then I will be equal to, integral will be equal to 2 pi I times summation of residues, sum of residues of all the singular points which lie inside the contour. There is only one singular point here, z equal to 0 is the only singular point which lie inside the contour. Therefore we have to calculate only the residue of f at z equal to 0 and we have to substitute it here. Now to calculate the residue of a singular point which is essential, what we do is we do Laurent series expansion and then take the coefficient of 1 by z minus z naught. This coefficient is also written as b1. So b1, this is equal to residue of f at z equal to z naught. So this method works for every type of singular point, but we use it especially for essential and removable singular points. So let's do the Lorentz expansion of z raised to 4 e raised to 1 by 2z. This is equal to z raised to 4 times 1 plus 1 by 2z plus 1 by 2z the whole square divided by 2 factorial plus 1 by 2z the whole cube divided by 3 factorial plus 1 by 2z the whole raised to 4 divided by 4 factorial plus 1 by 2z the whole raised to 5 divided by 5 factorial and so on. Now z naught here is equal to 0, therefore we are interested in the coefficient of 1 by z minus 0, that is 1 by z. We have to find the coefficient of 1 by z. That is what we are interested in. And to get coefficient of 1 by z, I will find the coefficient of z raised to 4 multiplied by this, because when you multiply z raised to 4 with this term, then you will get 1 by z. In all the other cases you will not get it. So let us write this product, z raised to 4 times 1 by 2z the whole raised to 5 divided by 5 factorial. This is equal to 1 by z raised to 4 times 1 by 32 1 by z raised to 5 whole divided by 5 factorial, which is equal to 1 by z 1 by 32 times 5 factorial. Therefore, the coefficient of 1 by z is 1 by 32 times 5 factorial. So B1 or residue, this is equal to residue of f at z equal to 0. This is equal to 1 by 32 times 5 factorial. Now let us substitute it here for finding the integral. I is equal to 2 pi I times summation of residues. There is only one residue and value of the residue is 1 by 32 times 5 factorial. This is equal to pi I divided by 1920. Therefore, the correct option here is option 4. Now, if the contour is traversed in clockwise direction, then you have to put negative sign. That is the only difference. But here we have counterclockwise, so we have the positive answer. That's all. Thank you.